Hey everybody, we're going to begin our first AP Calculus AB video. So over here we have two functions and their graphs. Now for the second one, we don't know the function, but you'll see what we're going to do with it in just a minute here. So in pre-calculus, you should have covered the basic idea of limits. And if you guys don't remember, basically a limit of a function is written like this. So limit as your variable x approaches some value, we'll call that value c, of your function, which is f of x. So this is what we call limit notation. Well, what does it graphically represent? Well, a limit approaches, as the limit as x approaches a certain value of your function is going to represent a specific value as well. So looking at the graph of f of x is equal to x squared, well, what would be the limit of any value of this function? Well, the limit as x approaches c is going to be c squared. Why? Because as x approaches c, f of x is going to approach the value of c squared. And, while it might not sound like the best explanation, it kind of just logically makes sense. So if you look at the graph here, what are we going to do with limits graphically? Well, we'll call this, this is our x and y axis, so obviously this is 0, 1, 2, -1, -2. Now, how do we do limits based off graphs? Well, let's say the first limit we're asked to evaluate is as x approaches 0 of f of x. And keep in mind, f of x here is going to be x squared. So actually, let's call this function g of x so we avoid confusion. But what is this value? Well, because we have a definite or defined function on our interval, we'll call this -2, -2, 2. Our function is continuous here, and we'll talk about what that means in just a second. So this video might be a little longer than usual. But as x approaches 0 of f of x, well, f of x is x squared, So what is x squared going to approach when x approaches 0? Well, if you look at our graph, x is approaching 0 from both sides, -2, -1, then 0, and then 2, 1, then 0. Now looking at the y values and the coordinates, what is the value, or what is the graph approaching as x gets closer and closer to this dot right here? Well, obviously it's approaching 0. Now graphically we can tell that this limit is going to be 0. But if we don't have a graph, for example, we would, because this function is continuous, we would be able to plug 0 in to our function, and 0 squared is still 0. So we're going to talk about two concepts. Really quickly, we'll go over continuity, and we're going to talk about infinite limits. So there are cases where you have functions where you don't have a defined limit. For example, looking at the graph of g of x, what if you were asked to solve for the limit as x approaches 0 of g of x? Well, looking at a graph, as x approaches this central line right here, this line, where x is equal to 0, we can see that our y value, or our g of x value, doesn't exactly approach a specific number. It's just going higher and higher and higher, and you can't quantify what that limit will be. So this is usually an infinite limit. So you'll see or run into a lot of limits like this during calculus. Now, to talk about continuity. Continuity of a function is when that function is simply defined over that specific interval. So, if we have x squared is defined over, our interval, in our case, -2, 2. But let's say we have a function that is maybe, x plus 5 over x minus 2, a rational function. Well, if you have x equals 2, you're going to get what? 2 plus 5 is 7 over 0. And we know that this number is actually undefined or does not exist. So how can you take the limit of something that does not exist? Well, that's what a continuous function does. To make that clear, for you to take the limit of this function at x equals 2, you cannot just plug it in like you did with this function because it's not continuous there. So continuity helps with limits. So in the next video, we're going to discuss in depth what continuity is, how you can solve and check whether a function is continuous, and if we have time, we'll figure out how to find the limit with a couple examples if the function is not continuous.